All right, before I dive in with my official intro, I want to say before that countdown, I asked the classes for the best dance moves, and I got to say, Miss Galley, you guys all got up and killed it, so way to go. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world through 50 live, free, interactive broadcasts every single month. So welcome back to the classroom for teachers. Welcome back to the classroom for all you students. And thank you so much for joining us in these first few weeks of the school year as we continue to showcase and celebrate such amazing people and places around the globe. So as many of you may know, certainly your teachers will know, this is a special week for us too. This is the Week of Wonder. So Science Literacy Week is happening coast to coast across Canada. This is hundreds of live, virtual, all sorts of cool events coast to coast. I say coast to coast a lot. Science Literacy Week, it's happening. It's very exciting. And as part of that, the Canadian Association of Science Centers, this body celebrating people that are working to connect students like you with the cosmos, the world around them. We are doing a 20-part epic program series with them. So this is day 4, program number 13. If you've joined us all week, all those programs are live on YouTube. We've got a bunch more today and a bunch more tomorrow to wrap up. But it's been really exciting doing this Week of Wonder, and I hope you guys are as jazzed as I am about it. So without further ado, today's topic is one of my favorites in the entire week. This is tracking climate change from space. Now, climate change is something we've been covering all week long. It's a really important, it's the most important topic in society right now. And so many of our speakers have been celebrating that. But today we're taking a bit of a different angle. How do we use satellites? How do we use these high-tech toys up in the sky to track and understand climate change and help us work towards mitigating it, and changing it, making it better for the world and for all of us? So without further ado, I'm going to turn it over to Joseph and Baravi at Indus. They're going to dive in on that topic and blow our minds. Thank you so much for joining us, you two, and take us away.
Thank you very much.
Hello, welcome everyone. I was quite bummed I couldn't see the actual dance moves when we got started, but I'm excited to meet everyone who's joining us from all across North America, I guess, at this point. Welcome everyone. My name is Dr. Bhairavi Shankar. I am the founder and CEO of Indus Space, together with Joey, who's also here. I feel like he will join us. Okay, yes. Mm-hmm. I am also a professional planetary scientist, and that's what I love to do. And so today's topic is just one of the many ways I enjoy looking at different pictures from across our solar system. But I'll also let Joey introduce himself.
Thank you, Bhairavi. My name is Joseph Ulmer. I am the curriculum developer here at Indus Space, and I am first and foremost a science communicator. So I'm all about making science and scientific topics more accessible for the wider public.
Yeah, so as Jesse mentioned, we're excited to celebrate as part of Science Literacy Week. And so we'll dive into how we actually start tracking climate change from space. So I'll be showing a couple of slides, but I would love for everyone to use the chat windows and share your feedback. Anytime I've asked a question, use the chat window, and I'll rely on Joey and Jesse to kind of fill me in on what answers might be coming in. So let's get started. Okay, this is a great picture that we can already start with. Who wants to tell me, what do you see from this picture? Describe it. Do you know what it is? Can you guess where it is? Let's hear. What does everyone think?
All right, so we've got our live classes joining us. I'm going to head to them in just a second. If you are on YouTube, you want to type in that chat bar, please do share your questions there too. And Joey, as we said, will answer those. Miss Galley's class, what do you guys think? What are we seeing in this picture?
What do you
see?
Trees.
Trees and
coastline.
Coastline? Okay. Bunch of good answers. All right.
Yeah, great job, everyone. Yes, you are seeing what I'm also seeing. So you're seeing a combination of trees. You're seeing the shorelines. Someone said coastline. It could be a beach. And the neat thing is that we are actually seeing it from, like, you can think of it from a bird's view, right? Imagine if you were a bird flying over all of this. This might be something that you're seeing. And you're already starting to notice different things just from this one picture. There is a road that tells us we're right here on Earth. That's a good clue to know where we are. But you're right. You're actually being able to see a lot more than you could if you were standing right there on ground. And this is exactly how satellites are used and really helps anyone who's interested to get that larger perspective, just so that you can start to look at patterns and trends before you decide you want to go and focus on a particular spot. So that was a great first job. And now I'm going to switch up a picture and ask you the same question. Tell me what you see, and where do you think we are now? Okay, let's hear back.
Right. I mean, we've got a coastline there in the bottom too. That's pretty exciting. Okay, if you guys are in the chat, let me know. Roden Public School, Mr. Lamb's class, come on up, unmute that mic. Let's see what you guys think. Where are we in this picture?
Los Angeles, nice.
Yeah.
Okay.
But unmute.
City.
Yell it out. LA for Miss Galley class, City for Miss Parishes. You can yell it out, guys, but you need to unmute your mic.
Is it in California?
California?
Good guess. I think I'll ask or wait for a few more suggestions before I reveal where it is.
Miss Parish's class, they wrote LA. We got California on the brain today. Okay. Definitely.
Okay, and actually, I'd like to also know, what is it about this picture that is giving you that sort of clue that maybe you're looking at a city? Was there anything in here that triggered that sort of a suggestion?
Yeah. Tell us, Roden.
It just looked like a lot of buildings and roads.
Yeah.
Buildings and roads. Okay, yes. So if you can see my mouse, I'm hoping it shows up. Yeah. You're right. You're seeing a lot of lines that are going quite across the picture. Some of these are roads, some of these are highways. Someone noticed this coastline over here, and there is some greenery, so it's not all just concrete jungle. There's a little less of it compared to the first picture, but we are seeing some greenery. And if you notice this out here, this is actually part of an airport. So good guess if it was Los Angeles or California, but yes, as someone has mentioned, it is Toronto. So you're seeing Pearson International Airport out here. This is Lake Ontario, the shorelines of it. And there is a whole lot of urban activity happening everywhere. There's the Buttonville Airport at the top right. And so this is, again, another way you might notice, and I've already written out, this is a Google Earth image. And this is what's called a true color image, because what you're seeing is realistically what's actually on ground. So now that we are aware of all of these images, I want to just take a moment to explain how is it that we actually get these images. So many of you might already know we've talked about satellites, but in reality, what's happening is, rather than us going to a location and physically being there, touching any surface, this is where you're launching a satellite. It is orbiting around Earth at different distances, somewhere within the parts of our atmosphere, and it is just taking readings. It is capturing data, and it is helping then the analysts and all the people back on the ground understand what exactly they're looking at. And so this has been happening for several decades. And as you can see, this picture is actually showing you a variety of satellites. I'll be talking a little more about the different kinds of satellites later on, but this is exactly how those pictures are being captured. And imagine, it is always happening, whether it is raining, if there's snow. It's just one really good way for everyone to know what's happening on a surface, even if you have any sort of a question that you want to explore. So now I have another guessing game. So this time I want you to look at this and now start to tell me, what do you think is happening on the surface? Okay, it's another Google Earth image, but tell us, what do you think is represented here? And again, explain, why do you think that is?
All right, so our second Roden Public School class where they got Toronto right, and they were the one to get that right. I'm going to come to you guys now. Unmute that mic. What do you guys think?
I see a volcano or a mountain.
I like it. That's a pretty strong
And what
name.
gave that away?
And so what was that?
Sorry, I was just asking what gave it away that it was a volcano or a mountain. Someone said crater.
Back to you guys. Oh, no, unmute again. Leave your mics on, everybody. It'll make it much easier. Nope, mics off, guys. You unmute yourselves again. Everyone can unmute. It'll be way easier in Q&A. There you go.
Don't do it. How did you know it was a volcano?
I think I see it's a volcano since I see some like land go up and I see crater in volcano.
So like out here.
Yeah.
Okay. A great observation. And you're actually right. For everyone who guessed this was a volcano, this is a volcano. So question is, do you know which volcano? But while you're thinking about that or using that in your, or writing out the answers in the chat box, I want to explain how this picture was actually taken. So you're again seeing a true color picture, what you might imagine in real life. There's some green areas. There's a lot of brown areas. There's some white area. So white could be representing snow, or it could be representing something that's just reflecting a lot more light. The greens are vegetation. The browns could be anything from roads, or it could just be a muddy lake maybe. So at this point, you're along the right tracks of it is a volcano. You're seeing this crater-like feature, but it looks kind of broken. But in reality, what actually happened was the satellite that was taking this image didn't just take it in that one style. It actually was taking data in a different set of bands. And so with each band, what that meant was the sensors were collecting that information using a different wavelength of interest. And now you might ask, who decides that? There will be a team that actually decides on what sort of wavelengths are important, depending on what the actual interest is. What is that question that you want this satellite or sensors to look into? And so that picture was just taken using three bands from this whole selection, and then creating the true color image that you could see, so that you could be like, oh yeah, that's greenery, that's actually vegetation. But in reality, what it is showing is the true color will only see what your eyes can see. And if you have learned about electromagnetic spectrum and things like that, you'll notice that our eyes can only see a little part of what's happening. There are many more wavelengths like radio, microwave, gamma, X-ray, all of that, that can actually pick up more information that for us, we just don't realize that it's there because our eyes are not trained to kind of pick that up. But this is where satellites and sensors come in super handy. So imagine if we were looking at that very same area, but now looking at it with a bit of a different combination, where we're now looking at infrared data along with some visible data. And so for that very same location that I showed, this is the next picture. It might look fuzzy, that's okay. But as this is a satellite that was called Landsat 1, and it took a picture of that very same area, but all the red over here indicates that it's really rich in vegetation. So all the greens that we saw before are now showing up as red. So who wants to use the chat window and tell me, how red is it? Are you seeing different ranges of red, or is it all just intensely red? You can use, again, the chat window to tell us.
I hope we're not all seeing the same red. This is like a color blindness test at the same time. Anyone in the chat wants to share? I'll leave it to YouTube class at this time. By the way, for your last question, like which volcano is this? We've got a lot of Hawaii, we've got Vesuvius, volcanoes in general, but Hawaii seems to be our common one. Lots of different. Okay. Yeah. Ms. Pierce.
Yeah, so I will keep an eye and I will reveal which volcano this is.
Okay.
But,
Mrs. Parrish's class, we have you guys in lots of different shades of red. Yes. Anything else you want to highlight in the image?
Anything else, guys? What else do you see? Lots of reds. They just keep saying lots of reds.
Lots of reds.
Lots of red. Darker shades of red closer to the volcano. That's right. So you are seeing a lot of reds. You're maybe seeing some, this is actually, the image is also overlapped over terrain. So sometimes what you're seeing is that roughness of the terrain, which is also coming across. But I mean, safe bet, all of that area that is red is actually vegetation. So now keep this in mind. I see Mount Fuji, good guess. This is now another picture, again, same location. This is now Landsat 4, a different satellite that was taking a picture. It looks a bit squished, I think, because of this presentation. But who wants to tell me, are you still seeing the same degrees of red? Has anything else changed? What's happening?
I think something else has changed. I think we got a lot of greenish, grayish stuff going on closer to the volcano. Where it was darker red earlier, maybe, is now this different color with our different satellite, which is pretty cool.
For sure. Okay, so This is another view of it. And now a final view. Ooh, Iceland. Interesting. I love all the guesses. Okay, final red picture of this very same area. So how much red is here? How does it compare to the previous red picture? Or even the first one?
We got different reds in different places, it looks like. We got a little bit less red. We got this gray in the middle, right around the cinder cone. Very red, Mrs. Parrish's class, with some gray.
Yeah.
I like it, guys. You guys are great in the chat. And then tons of people on YouTube too. Green and blue. Grade 5, 6 Miss May's class says it looks like mold. Was our last one, I guess. There we go.
Yeah. Okay. Great job, everyone. I love how, you're all observing. There are different ranges of reds. Dark spots might be water. I like that guess. So drum roll, this is what this feature was. And to the teachers, this might be something also familiar from back in the day. You are seeing Mount St. Helens, which is out in the state of Washington. And this, what we were seeing are different views of that same area at different times. So this is a picture I looked up on the internet. It was Mount St. Helens back in the mid-70s. Very nice, as you saw in that first picture, which I will bring back up. You saw a very nice, distinct feature right here in the middle. And that was, sure, a volcano. There was some white on the very center of it. Could have been snow and could have been anything else. But there's a lot of red around that, and that indicated vegetation. Good eye if someone was spotting this and indicated the dark spots may be water. This is one of the neat ways that these are called false color pictures. Remember how I introduced true color pictures back when we showed some Google Earth images? This is a false color because you're actually combining different bands and wavelengths into different combinations as suits you to kind of learn a little bit more. So this is a false color composite image, which is showing how the reds are all vegetation. Back in the 70s, this picture was taken back in 1973, and this is showing how the landscape was. Next, what we have is, well, I don't have an actual picture. If you do search on YouTube, you can see the actual eruption event. But in 1980, the volcano erupted. It caught everyone by surprise, and it was pretty catastrophic. There was quite some ash that was spewed out. A lot of lava flowed out, and it happened to happen so suddenly that, in fact, a few years later, back in 1983, this is how the landscape looked like. This was the second picture I had asked you about. So now in this time, you're noticing, and everyone had mentioned that, there was a lot less red areas in this area, and you could actually see this brownish, greenish kind of thing. This is showing you, this is where the volcano is. It erupted. You're now starting to see a crater. And guess what? This is all the blue, the brownish green is all the area that lava spewed out. Imagine what has happened to the vegetation. It's actually missing. That kind of shows you how satellite imagery kind of helps you get a bigger, wider picture of just how much damage happened. Some areas were untouched. So that area right by where you see the water feature did not see a whole lot of change, but anything right immediately closer to the volcano. And this, by close, I mean, this is easily going several tens, if not hundreds of kilometers away from the actual volcano. So you're able to see that there was some modifications to the landscape. And now, finally, that last picture that I'm showing is, okay, again, another Google image search. This was taken of how Mount St. Helens looks currently. You can still see that collapsed crater. And this is from a visitor area a bit far away. When it's safe to travel back, I highly recommend going and visiting this because it is really mind-blowing to see how this volcano has really modified the landscape and that eruption. And the final red picture that I had shown you was actually taken in 2014, a good 30 plus years after that main eruption. And if you're noticing, there's still some reds that have come back. Guess what? That actually helps us understand, even if the eruption event was pretty catastrophic, destructive, and there was a whole lot of damage that came from that, 30 years on, the actual land has managed to figure out how to regrow some of that vegetation. And this is where, again, satellite imagery can help you understand what's there and what might also happen after, if you want to start planning about how do you ensure you keep everyone safe and things like that. So I did spend a lot of time on this, but really this is the focus on really how satellites can help us understand what is happening on our planet. And when it comes to climate change, really, how much do we need to, how much we can use this information to prepare ourselves and know what to do if we want to have, address any impact from climate change. So as we move along, I mentioned about the electromagnetic spectrum. This is the wide range of all the different wavelengths that we can use to find that information. When I talked about false color pictures or composite maps, this is often the sort of combination that you can use in order to know, okay, if we want to look at something like plant health, how do we tell? What do we need to do from a satellite perspective? We need to get information that's partly from infrared range, partly from the red channels that we can technically see, and partly from the green. If you combine it in that, it'll tell you plant health, kind of like what we saw in Mount St. Helens. Now, if you want to look at, say, the impact of floods or how floods or how fire has really changed the landscape, you want to use a different sort of combination. And similarly, if you want to look at the presence of ice or lack of ice, you kind of use a different set of combinations. These are just a very small, basic example of what you could use to combine. But the key is that if you're sending a satellite up into space, you want to kind of use or get it to have as many different options ready so that it'll help you actually investigate and actually see how it matters to whatever your question is. Speaking of climate change, that very same idea of using the infrared channel to identify vegetation really helped in this example. So this is the island of Evie, second largest island in Greece. And this is what they captured. So the European Space Agency launched back in, I think, 2013 or something, the Copernicus Sentinel-2 satellite. This has about 13 bands. And now in 2021, they were mapping it and they took a picture of this island and they noticed that, image was taken back in August 11th of 2021. So just a month or so ago. And what they had noticed was, and you can use the chat window to tell me how much red are you seeing? What do you think is happening over here, given that it is talking about wildfires? Any thoughts?
All right, guys. Miss Parrish's class, we haven't brought you in live in a while, so come on in. What do you guys think? Regards to wildfires, what's happening in this picture?
What do you guys see?
Red. What does the red mean, though? What do you think it means? Fire. Those are areas that are actively on fire. I mean, it's a good color for it, I think. Okay.
That is true. It can get easily confusing or mixed in that sense. So the reds over here in this picture are telling you where there is rich and healthy vegetation. So trees, plants, all of that. That's showing you how the reds are. And the deeper the red, the healthier the plant. But if you notice somewhere along the sort of western edge, and as you move toward the north, you're not seeing a whole lot of that. In fact, towards the north, what you're seeing is a whole lot of greens and grays, browns and things like that. And that is showing you how much that wildfire has actually removed any vegetation. You're not seeing a whole lot of healthy vegetation. And this image was actually helpful for the teams when they were on ground to kind of figure out, okay, we need to go and find out where these fires are and help actually put it out. So this picture was taken on August 11th, but the actual fires started August 3rd. So in a span of a week, you can see how much the fire has progressed throughout the island and actually started to impact on the vegetation that's out there. So hopefully it's making sense about just how important satellites are in helping us figure out what's happening, how we can use different combinations. I want to now spend the later half of my talk to explain what other kinds of satellites exist and really how does that help maybe not just for vegetation. I'll ask you a little bit later on how you think, where else we can use these satellites. I want to spend a moment to talk about the RADARSAT Constellation mission. This is one. It's Constellation because there are 3 satellites. They're kind of going piggyback with each other. They're orbiting the Earth. This was designed and made and funded through the Canadian Space Agency with a lot of local companies across Canada that helped put it together and then launch it. And so the RADARSAT Constellation series of satellites orbits at 600 kilometers above Earth. So it has a pretty high view, perched view. It launched in 2019, but this was not the first time. There was RADARSAT 1, RADARSAT 2. This is the most current version of it. And then there are, as mentioned, 3 satellites that are orbiting behind each other. And it weighs, each satellite, imagine, weighs about the size of a black rhino. That might hopefully give you an idea on how big or large and heavy these satellites can get. But once they're launched into orbit, it's gravity that's holding them, but they're not also going to crash and come back into Earth because they're in a fixed orbit. So that was it uses, in terms of what kind of wavelength this is using, RADARSAT mission are all using the radar wavelength. And guess what? Radar wavelength is great because it can actually, it doesn't matter if if you have a cloudy day or there's a lot of snow happening, radar can actually come through that snow, the clouds, and actually just map whatever the surface looks like. So again, this is great. You don't have to wait for a perfect moment to take those images. It can happen every day, 365 days a year. And so since 2019, this mission has been collecting about 250,000 pictures each year. Imagine, of the entire globe. And so it can actually help with so many things. And it does. So that's about RADARSAT. So I want to ask you now that I've mentioned a few scenarios, few examples, and about RADARSAT, who do you think, my final questions to all of you, who do you think will use information like this? This type of data, whether it's vegetation or this wildfire or even the radar data. Can I ask from the classes? Like,
hey, yeah, we're going to have both road and public school classes. So Doug's class, and then we'll go to Mr. Lamb's class in a second. What do we think? Who would need this type of data?
Scientists.
News, Google Earth, scientists, astronauts. Okay.
Good things in the chat, everybody. Mr. Lamb's class, what do you guys think?
Come on up. We got another one coming. Quick. What do you think?
Weather people?
No worries, no hurry, guys. All good. casual programs.
Google Earth.
Google Earth did use it.
Meteorologists.
You guys grew up in an age where Google Earth was so natural. Like this fact that we can see all this stuff is like mind blowing even to me to this day. So very cool. Okay, so scientists, Google, when we're making these maps that are real, first responders from Miss Galley's class, archaeologists. You guys are like the most engaged chat group ever in the whole week. I love you all. This is awesome.
Amazing. So I saw a few of these, but I just want to also mention there are a lot more. So imagine if you are working with the government and you want to make sure you can keep an eye on all the ships that are coming across along the coast from different countries. Satellites might help you actually figure out, okay, which ship is coming? Are they kind of like air traffic controllers? Like, do we know what this ship is? Where is it coming from? Is it supposed to be here? It helps protect the borders. That's one example. Someone mentioned about first responders. Absolutely. So if you want to know if there is a fire, or if there is a flood, and you want to know where to send people, a satellite view can actually help you figure out, okay, we need to go here first, or maybe somewhere else. And this helps everyone kind of triage what that plan will be in the immediate moment when there is a disaster happening and everyone needs to figure out how to get people out safely. Not just people, animals. How do we make sure our wildlife are protected? Because with urbanization, maybe we're creating new roads, or maybe we're creating actually taking away from their natural ecosystems. But we want to ensure that they have a safe place to be able to live and actually flourish. And so satellites will be helpful with that. Farmers could use satellite data if they want to know what kind of crops they should grow, what's healthy, is it possible or safe to do it here. Having that bird's eye perspective will really be very helpful. So this is a bit of a screenshot or like a word cloud of all the different possibilities, but I'm sure there are many more. If you want to monitor pollution, air pollution was in the news either yesterday or today, and this is one way that you can send sensors. There's another Canadian company, GHG Sat, that they are actually using images or data from satellites to help monitor how much greenhouse gas is happening around the world, and helping then companies figure out, okay, how do we mitigate this, make sure there isn't a whole lot being released, right? Because again, all of that will only fuel the climate change process even faster. So hopefully this gives you a perspective. And with RADARSAT, for example, you can use it to monitor ice movement. The presence of ice in northern communities, very important because many communities rely on it. So yet another way that satellite information will be helpful. So in the last few moments that I have my slides before we go into questions, I want to now, for a brief moment, take us just outside of Earth and see, well, can we actually use the satellite data elsewhere to understand climate around our solar system? So if you were wondering about that, yes, you can. So very quickly, I'll mention how there is a satellite called, a mission called Mars Reconnaissance Orbiter. It is orbiting Mars. It has been since since 2006. So it's been quite a while. And it has been orbiting Mars and has a whole suite of instruments to help it understand what Mars's landscapes look like. And one of those instruments is called HiRISE. So it's a very high resolution camera on the satellite that is taking pictures of the surface. And when I say like high resolution, I mean it's like 25 centimeters per pixel, which is like, what is 25 centimeters around you? Like, look at a ruler. You see how small that is. That's what is the level of detail that's available in a pixel. So sometimes you can use that information to really look at minor modifications that are happening in the Martian surface and help understand broader questions like, okay, is there water? Is there, how often does this water come? And so this picture that I'm about to show you is an example of a HiRISE picture. This was taken around the northern polar regions. And what you're seeing are just layers and layers. They look like lines very, evenly going across the image. But this is an area where they're looking at it during Mars spring to understand if avalanches happen. How many have heard of avalanches on Earth? There is a possibility of that process also happening on Mars. So it would help Mars scientists understand, okay, what does the planet look like? How is it different from early Mars when, maybe conditions were very much warmer? And so the question is that snow? I mean, I can't say yes for sure, but yeah, there is some mixture of rock and ice. Now, is that ice made up of water, or is it made up of carbon dioxide? That's not known from this picture, but that is certainly something that Mars scientists are looking at in detail, looking at the seasons on Mars, just to see if, that'll help understand what the geology is like, what are the rocks made up of, and also eventually, is there water, and so on and so forth. So that is one example where that sort of data set is helpful in understanding climate around other planets. And the final one that I'm going to mention is Venus. So you may all know that Venus is very hot, very true. Surface is like super hot that I don't know that it's safe for any of us to go and actually explore that. But there are 2 missions down the road that will be exploring the atmosphere of Venus. And they want to see if that is possible to maybe have like a bit of a habitat along the atmosphere area, not on the surface. But Venus, we know, is very much a greenhouse gas kind of rich atmosphere. When you look at it with just your eyes, you're going to see the picture on the left. Not much you can tell. But back in the 1990s, they sent a mission called Magellan. And that mission was able to it had a radar instrument. And remember from RADARSAT, same idea. This radar instrument was able to look through the clouds, and what it found out was really how topographically different Venus is. If you're looking on the picture on the right, anything that has a warm color means that it's higher elevation. Anything that's in a cooler color, it means that it is lower elevation. So Venus has a whole lot of tectonics and movement of its crust that wasn't known before we sent this mission. So hopefully it helps you understand how sending a satellite with a whole lot of sensors is really helpful. I'll end off by saying these are examples of, current missions or data. But if you want to go and explore any more, I'll highly recommend a few sources. So this is a screenshot of Planet. It's a large company that takes, again, satellite images, and they are doing a whole lot of effort to understand just how different surfaces are, what's happening over there, whether it's a fire event or if it's a drought event or anything like that. So they have an amazing gallery. If you want to go and look at their gallery, you can see a lot of these high resolution pictures and just browse through different corners of our planet. And finally, on this topic of climate, and if you want to participate and be a citizen scientist, I came across this, which is really neat. And I believe now they are welcoming new interests. So to all the teachers, if your classrooms want to participate in this, please do reach out to them. This is where you can go and observe and make your own observations about how the ice is around where you are, whether it's right by your street or by a lake or pond or anything else. And that may help join the broader study that everyone is doing around looking at the impacts of climate change. So with that, I feel like I've taken a little longer than I anticipated. So I will say thank you, and we can now switch into question modes. Hope this was helpful and insightful about learning about how satellites help us.
Fantastic, Ravi. That was awesome. If you want to come out of screen share so you can see us, have a bit of a conversation, great. The good news is you guys are the most engaged class ever, so I'm going to come to each one of the classes in turn, one by one. We'll try and take a few from YouTube as well. Bad news is we are a little long, so I will highlight those resources again if you guys want to keep the learning going when you're done. But let's dive in. We'll go to our first Roden Public School class, Doug's class. You guys have 2 students there. Welcome in, guys. Kick us off with a question.
Hello.
Hey.
Just say it.
Can you hear us?
Yeah, you're good.
Yes.
Okay, so we would like to know how bad is pollution in space because of Earth?
How bad is pollution in space because of Earth?
It's a new one.
Good question.
Before.
I don't know that I have an actual exact amount, but I mean, in reality, not a whole lot is my guess, because when you really look at it, it's a very small percentage that have actually gone out. And even then, it's not, to my knowledge, polluting. The only concern I will mention is around the satellites that are orbiting Earth. There are different kinds of satellites. I only explained a subset because of its relevance to looking at climate change. But you have satellites that are there that are also for telecommunications or any other purposes, right? So there is there is conversations on ensuring how, when a satellite gets launched, it is not going to bump into some other satellite. And there is efforts being made to have a general global consensus of, okay, what's the plan? What's the process? How do we make sure if a satellite is no longer working, what are we going to do about it? Is it just going to sit in orbit, or is it going to deorbit? If it does deorbit, we want to make sure it doesn't hit anyone accidentally or purposely, and things like that, right? So there's a lot of discussion happening, but that is something maybe that hopefully helps address your question.
I love it. The purposeful satellite hitting is an image that will stick with me long after this broadcast. That's one way to do someone in. One of the coolest things on this note, I guess, is when we send probes to other planets, like when we send them to explore the moons of Saturn, we want to really make sure that they don't land inadvertently and possibly bring some of our microbes to those ecosystems. And so they always deliberately crash them into the planet, which blows them up and means that nothing could possibly survive, which is a really cool, I guess, example of space pollution in action. Neat question, guys. All right, yeah. Mr. Lamb's class, come on in. And yeah, I love the Marvel shirt.
Hello.
Hi.
You guys, I think it was a couple of months ago, you got the first photo of a black hole. I was just wondering if there was any news about what would happen if you went into a black hole.
Yes, the black hole question.
Oh, can you? I missed the second part of it.
Yeah.
Jesse, did you hear?
So the question is that a few months ago we got a picture of a black hole for the very first time. It was a really amazing scientific accomplishment. The question is, what would happen if you go into a black hole? I know this isn't your main area of expertise, but I can dive in on this.
I will mention a little bit, Jesse. By all means, jump in if you feel I've missed on anything. But really, if you go into a black hole, you can't come out. So get ready to really make that decision if you do want to go into a black hole. But that's the whole purpose. Like the whole black holes in general will suck everything around it, right? So even light will not escape. So it is not quite possible to come out of that. And even then, if what scientists are seeing is what's happening to the area around a black hole, and that's how they are able to understand what the black hole is actually doing.
Yeah.
But
I guess my only two additions are we do not have yet the technology to get anywhere near a black hole. Like we have just barely come up with probes and rockets that can get us outside of our solar system. The nearest black hole would be like hundreds of thousands of years to get it at our current rate of speed. But if we magically made that happen, it's the best death in the history of the universe. Spaghettification is the name of how you die if you go into a black hole, where it literally pulls the atoms from your feet so much more than the atoms of your head, because it's that strong that it pulls you apart atom by atom. It's very, very cool, very nerdy. Way to go, guys. All right, Miss Galley's class, come on in for a question and take us away. Hey, Miss Galley's group.
Do you want to come up? You can ask yours. And then Eli, do you want to come up and maybe they'll take some.
so I can hear you, but I'm just going to grab my charger because apparently I have 10 minutes, so I don't want to hang up. I'll be right back.
Go for it. Hey, Galley's class.
What happens if lava hits water?
Ooh, I like it. Unexpected. Oh, Joseph's here. He's going to answer this one while Brian's getting her thing. Go for it.
Yeah, no problem. So yes, so lava forming water, you can kind of imagine it's like any time of instance where you have lava is going to be superheated. So it's going to be a very hot thing, and water tends to be fairly cold. So it's going to hit a cold thing. So two things would really happen with that. One, a lot of the water is going to instantly evaporate. You know, the process of evaporation where it escapes into the atmosphere. So as steam, so a lot of the water will steam away. But as a result of that, also a lot of the lava will cool down. And for those, if we're not familiar with what that is, lava is essentially melted rock. So what oftentimes happens when you get lava interacting with water is it will cool down and form into like different types of rock. I know it depends on what kind of rock necessarily. I know one of the kinds is obsidian, and there's various other forms of like rocks and minerals. In fact, a lot of I think it is igneous rock of the three major rock groups that's formed from essentially cooling off lava. So lava can cool off in many different ways. Introducing it to water is probably the fastest.
It's the coolest thing. I really do encourage every class. It's not even remotely related to much of this presentation, but if you guys want to check that out when you're done, it's one of the coolest things in nature. And Joseph, thanks for being in the background as we got that all done. You guys are so enthusiastic. I love it. All right, guys, time flies and you're having fun. So what I want to do is go to Miss Parrish's class to wrap us up with a question. Come on in, guys, and take us away.
Is there a way to erase a carbon footprint?
Ooh, interesting questions today, guys.
Sorry, I heard again parts of it.
Yeah.
Is there a way?
Is there a way to erase a carbon footprint? So that, yeah.
Oh, wow. I think, I mean, the simplest answer to me is plant more trees.
Yeah. So this is, I mean, again, you've been getting these questions outside of the main realm of the presentation, which is awesome. I'm so glad your guys' inquiries have gone on the various fronts from the climate more. But yeah, the way to undo what we've done in terms of putting carbon into the atmosphere is to do things that either draw that carbon out of the atmosphere or work to mitigate our own impacts, whether that's planting trees, whether that's, again, reducing our emissions, working on things on a factory level like carbon capture and storage. So there's a lot of really, the entire world scientific community is working on figuring out exactly how to do this, how to reduce our carbon footprint, how to mitigate what we put into the atmosphere. So this is the biggest area of research on the planet right now. It's a really exciting time if you're interested in things like that. So I love the question.
But while that's happening, certainly for you at home, the first thing you could do is also just have more greenery around you. If it's possible for you to build or plant a tree somewhere in your neighborhood or anywhere else around you, that is certainly helping in that. It is a small effort, but it's still an effort. So I think we can encourage you to do that as well.
Fantastic. Barabi, I know we could go all day with this. We know our classes are leaving for lunch and other things right now. So what I want to do is highlight some of the resources that you shared with us so the kids can keep the excitement going. First and foremost, everyone should head to indusspace.ca, an amazing organization. You can check out more of their virtual resources, programs for educators, curricula helpers. It's fantastic. It's been so much fun during Week of Wonder to highlight these amazing places. So really, if you're joining us live on YouTube, if you're joining us live, check out their website. Check them out on social media too at IndusSpaceCA. Lots of really, really neat stuff there, and always posting, of course, about the coolest and best and brightest in space. And the two resources that Ravi mentioned, planet.com, check that out. A very generic, I guess, URL, but very, very neat stuff. And IceWatch. There are more citizen science projects than ever. It is so, so cool. There are so many opportunities to be excited and to actually contribute to real science. So if you want to check out naturewatch.ca, all their programs, but specifically IceWatch today, I really encourage you to do so. Ravi, is there one last message we want to leave the classes with before we wrap up today?
I am so thrilled, and thank you to Jesse and the CASC community for having us on. It has been amazing to meet you, teachers and students from across our country, and great questions. So I was really excited to see that. So, and one more additional resource is check out space agency pages. So Canadian Space Agency, NASA, ESA, the European one, everyone is talking about all of these topics. So a lot of satellite information will all be in there as well.
Fantastic. I'll bring back in Joseph as well. Thank you too so much for joining us today. And what we do at the end of every broadcast, I'm going to bring in all our live teachers. So both our Roden Public Schools, Miss Galley, Miss Parrish, if you guys could all join me in saying a big thank you and farewell. Thank you so much for joining today, guys. Have a wonderful day.
Bye.
Bye, everybody.